the power of 2x plus 3, which equal to 2, to 8. If we would like to take len for both sides, it's gonna be len over 4 times e to the power of 2x plus 3, which is gonna equal to len 8. Start first taking advantage from the multiplication process here. So it's gonna be len 4 plus ln over e to the power of 2x plus 3. That's gonna equal to len 8, which is gonna deliver len e to the power of 2x plus 3, which is gonna lead to len 8 minus len 4. This way you will have 2x plus 3, which is gonna equal to len 8 over 4. That's 2x plus 3 is gonna equal to len 2. Start to isolate the value of x, which is simply gonna lead to x of len 2 minus 3 over 2. And now you have the value of x exactly like this one. So hopefully the steps are clear for you. Also, please, in this part, study well the problems that deal with exponential functions and also with arithmetic functions. And keep in mind that all times, if I want to solve an exponential function, start to think about the exponential probabilities. If I want to deal with exponential functions, don't forbid yourself from going through thinking about the arithmetic function, or take advantage from the arithmetic function properties. For problem number 5 is just simply giving you a couple of questions about limits, and he chose simple questions about limits. He's giving you the limit of x tends to 0 of tan x over x versus limit x tends to infinity of x minus 3 over x plus 1 to the power of x. The first problem is very, very simple. You can solve it using logarithm. Now you can use logarithm in most of your problems. The other problem, it will be easier to use the logarithm I'm gonna write for you. For the first problem, simply, once you start substituting, it's gonna be 0 over 0. So simply I can use logarithm. And so it's gonna lead to limit over x tends to 0, which is gonna develop 6 squared of x developed by 1. Start substituting, it's gonna be 1 over 1, which is 1, and this is gonna be the solution as quick as you can see. Also, we can separate this problem, limit x tends to 0, to be sine of x over x times the limit of x tends to 0, 1 over cosine of x. Once you start substituting, you will find this function is equal to 1, that's also equal to 1, and the limit for this function will equal simply to positive. If I want to go for the second problem, which is a little bit need more action from you, if you start substituting, you will have infinity by infinity to the power of infinity, which is really, it's undefined quantity, but let's see this one. If we try to hold this function to be on the form limit x tends to infinity of x plus 1 minus 4 divided by x plus 1 to the power of x, simply all I had to do is to add positive 1, negative 1. I just am aiming to reach this form that I've told you about previously. Limit x tends to whatever of 1 plus f of x to the power of g of x. If you substitute, and it's going to be 1 plus 0 to the power of infinity, you have the right to evaluate this limit instead. Limit x tends to whatever times f of x times g of x. I'm trying to reach this loop. So this is why I've added positive 1, subtracted it from the denominator. Simply, you will have a limit of x tends to infinity of 1 plus negative 4 divided by x plus 1 to the power of x. If you start substituting, it's going to be 1 plus a 0 to the power of infinity, and which is simply gonna allow you to use this law, e to the power of limit x tends to infinity, start multiplying f of x by g of x. So simply it's gonna be negative 4x divided by x plus 1. Just using bracket, it's infinity by infinity, or dividing both the numerator and the denominator by the highest power that exists in the denominator, which is x, you will have e to the power of negative 4, and this is your final answer. It's going to be e to the power of negative 4. Evaluation of this part is very, very simple. Once you use logical, or remember to divide on x, both the denominator and the denominator. If you have problems with this side, you will have to solve a couple of problems with logical. You have a lot of problems in limits, either in this part with the beginning of the chapter 1 in functions, or in the application of derivative down the road. Okay. Here's asking you about finding the derivative of these functions. All these functions are already solved in the previous vid that I recorded earlier, so I'm not going to waste a lot of time going through these problems, but I believe that I should solve number D using the advantage of logarithmic function, since in the previous videos I've sorted this function as a multiplication. If I want to solve problem number D, it's very, very simple. I would recommend you to solve all of these problems by yourself. I have y, which equal to tan to the power of x times 10x. This is times sine of x times sine minus 1x. Start, take length for both sides once more. This is not the only solution. There's another solution that I solved here earlier this morning, and you will find the lecture reading on the YouTube channel. But now I can solve it using len. So simply I'm going to take len for both sides of this problem, and this is going to be len of y equal to. You can see this problem is multiplied by this one, is multiplied by that one. So taking len will help you out to separate these functions. So simply it's going to be len over 10 to the power of x 10x, then plus len of sine x, then plus another len times sine minus 1. Once more, this is the second solution for this problem. Start the differentiation, stop, wait. Before differentiating, still also, I have len y, which equal to x times tan x times len 10 plus a len of sine of x plus a len of sine minus 1 of x. Start differentiating, so we will have y dash over y, which is going to equal to either tan of x times then plus x times sec square x, all of this times len 10, then plus, if we start to differentiate them, it's going to be 1 over sine of x, differentiating sine x, which is cosine x, plus abbreviation for len, which is going to be 1 divided by sine minus 1 x times the derivative of sine minus 1x, which is 1 over the root of 1 minus x squared. This way you have a differentiation for all of this function. Final step, I will move y from here and I will rewrite it in here. This is times y, and I will make a substitution replacing this value of y by the exact value, which is 10 to the power of x tan x. I will replace it by this function. So the final result is this part times y, which is simply 10 to the power of x tan x sine x sine minus 1x. This problem really solved it, and all of this really solved it in the previous video. So you about solved solutions. You find partial derivative for this function and also for that one, and they are already solved in the previous video. I would like to go through a parametric, to remember you with the parametric derivative of this function. Just a second. He's given you x as a function in t, which equal to 3t minus sine 2t. From this function, I can easily get dx by dt, start differentiating, which is gonna be 3 minus differentiate sine 2t is gonna be 2 times cosine 2 of t. Then I have y of t. And yt is 1 minus 3 of cosine t, which simply can be written as dy by dt. Start differentiating with respect to t. And this is going to develop 3 times sine t. Now I can use the parametric rule that states if you would like to find dy by dx, first get dy by dt times dt by d of x, which is going to simply be put in the form 3 of sine t times dt by dx, which is actually I'm going to get the reciprocal of this function, which is 1 over 3 minus 2 of cosine 2t. And this way, y dash is going to be 3 of sine t divided by 3 minus 2 of cosine 2t, and this is the final answer for y dash as you can see. The other two problems, this problem which is about the partial derivative, and that function which is about the implicit derivative, already exists in the previous video, so I don't think that I should resolve it again. I will just make this bit more longer, and there is no need for that. Here he's asking you about to use Taylor or Maclaurin expansion, whatever, in order to find the value of the square root of 5. And this problem, and there is a bunch of problems like this really exist in the main part of application using Maclaurin and Taylor. All I have to do is to get an expansion of root x, but to the nearest value that has a square root, which is simply going to be 4. So I've started with writing the Maclaurin law or the Taylor law. For my case here, it's going to be the Taylor law. Then I start stating that y equal root x, y dash, which is going to be the derivative of root x, 1 over 2 root x, y double dash, start differentiating, getting the second derivative. Then treble derivative, I start to differentiate for the third time. I've replaced every x with 4, getting the values of f of 4, f dash of 4, f double dash 4, f treble of 4. Those are the values. I've rewrote the Maclaurin expansion. I've start substitution in it. It's a function, it's a series in x, so I will start to replace every x from these values by the value actually that I need to find its square root, which is 5. So you will end up having 5, and instead of each x of those, I will replace 5, and you will have your approximate value as you can see. I will stop at this point, and I will continue on a later thread for the part of the investigation and the integration of classwork 2. Thank you very much. I've been with you today. I'm very, very happy to be with you in this quick revision. Please do review the ordinary differential part and the higher differential integration part that already exists in your course. It's really very important. On next thread, I will continue on the investigation of functions, and also I will go through integration. Thank you very much. I enjoyed being with you today, and I will continue next time, inshallah. Thank you very much. Wish you the best of luck in your exams. Thank you. Thank you very much. Bye.